Hey everybody, welcome to another live stream event. I wanted to talk a little bit more about Call for Code like I usually do. And then we have a special guest here today who is going to go over some pretty useful information. It's Elysa Jones. She's the chair of OASIS Emergency Management Technical Committee, and she's going to talk about some protocol and some just helpful things when it comes to emergency. So let's not waste too much time, and I'm just going to briefly just go over something here quick, and then we'll switch right over to you, Elysa. Okay. So as most of you probably know, our 2019 Call for Code Challenge is well underway. This year, specifically, Call for Code, we're targeting an emphasis on individual health and community well-being, which is part of what Elysa is going to talk about here. So I'm going to give her some time to do so. So Elysa, it's all you. Thanks for being here.
Thank you so much, Derek. I'm very grateful to be here, and I'm grateful to Kevin Allen of IBM and the Call for Code content manager who I met in Mauritius at the Global Emergency Telecommunications Conference in March. So that opened this door, and thank you so much for giving me the opportunity to share what we do in the OASIS Emergency Management Technical Committee. I have a number of slides here, and I'm going to kind of go fast through them, but I know they're available, and we'll hopefully have some time at the end for questions. So I'll start with the agenda here. I'll go over what OASIS is. The emergency data exchange language is what I'll focus on the most. Data interoperability, CAP around the world. CAP is one of our flagship standards. I'll give an overview of EDXL, and then also wind up then with specifications for healthcare in particular, and then some references that would be useful for you. So OASIS, if you don't know, Organization for the Advancement of Structured Information Standards. It's one of the top 3 ICT consortia. That's information communication technology, of course. And there's an EU regulation that allows the OASIS specs to be referenced in public procurement. So it's worthwhile to know and have these specs at your fingertips when you're developing code. They're very useful and very helpful. So the OASIS community is a permanent member of the EC's European Multi-Stakeholder Platform on ICTs, and we have an ANSI accredited process. You see some, but not all, of the liaison organizations that we work with there on the slide. So we do have an established presence. OASIS has been around since 1993. We have over 5,000 participants. Some of you may even work for companies that are members of OASIS, and you may not even realize it, but there may be a membership for your organization, and if you have membership, you have access to all of the technical committees, and there are over 700 of them. You see the chart there showing about 51% North American, but 35% Europe and 14% Asian. So we have a broad portfolio of technical committees, only a few listed there, but highlighted, of course, is emergency management. I've been the chair of this technical committee since 2004, a long time. So it's something I am very passionate about and delighted about the work we've done. I'm happy to share it with you today. So a lot of the OASIS standards are also accepted and approved as other de jure standards in ISO, ICT, ITU, and then I'll call out particularly the Common Alerting Protocol, which I'll talk about some today, just to give you an idea of the breadth of and capabilities of a very small and what could be insignificant is a very significant standard. It's also approved as an ITU recommendation 1303. And then I've highlighted also the Hospital Availability Exchange Standard, as we have now completed a cross-paradigm work with HL7, which is another international standards body who cares about the messaging within hospitals. So just to give you an idea about the Common Alerting Protocol and how significant a very simple standard can be. In the past, we had siren systems that would warn of a tsunami. We had emergency alert systems that would warn of a tornado. We had different dissemination systems for different types of threats. What the Common Alerting Protocol has allowed us to do, and this is all about interoperability, you'll hear me talk about that a lot. On the left there, you see all of the different threats and hazards that can be codified in a very simple CAP XML standard format. And then any of the dissemination methods can be used. without regard to the hazard, and using the capabilities of CAP with the urgency, severity, and certainty, the headline and description fields can allow systems to be built with that standard that will very appropriately alert and warn people in crisis situations. So just to give you an idea of what happens when free, open, international standards come into play, you see that tremendous usage. So in the green there are countries around the world that have operational systems today based on the Common Alerting Protocol. These are national systems. Over half of the world's population are now alerted using a Common Alerting Protocol standard. In yellow are those that are under development. In our last meeting just a couple of months ago, the Saudis and the Indios and the folks in India have completed their prototype development and will be rolling out their systems. So very soon we're going to see almost 3/4 of the world's population alerted with CAP. And those in gray are just simply unknown, although I know my friend Elliot Christian has been out in Western Africa doing a lot of work to promote CAP. CAP was also picked up by the World Meteorological Organization, the WMO, and promoted to all of the member countries. So it's just growing in all kinds of ways. So I'll mention now, I'm not going to read these, of course, but just to give you a list of the national systems in the Americas and throughout Europe. And then you talk about the NGOs and commercial systems. So Google Public Alerts is also based on the Common Alerting Protocol. Also the IFRC, International Federation of Red Cross and Red Crescent Societies, and many other commercial weather alerting systems. But not just that, sensors emit CAP messages. So you can actually have sensors that detect, say, the P waves in the earth before the earth shakes. And you can do meaningful things with that data because it can be transmitted so fast. And in such a simple format, you can have your dissemination systems actually utilize that message. So if the earth has not shaken yet, and you can stop elevators and open doors on a floor, or stop surgeries that would be in progress, these are huge life-saving events. Other CAP-based systems like the IBM Intelligent Operations Center, Microsoft CityNext, and many other systems are based on CAP. So I say that just to tell you just how important it is that free, open international standards can be played into for the purpose of interoperability. These are a list of resources. All of these are links where you can go and check at a later date about any implementations by country, other references. There's a great little 10-minute CAP video there as well. So just a little bit of a taste of what can happen when you employ such. So now let's think, what is data sharing all about? We talked just now about data sharing and how the Common Alerting Protocol provides for interoperability. Ineffective communication makes it very hard to prepare and collaborate, and response and decision making is slow, and we risk lives when we don't share data. It's a tremendous challenge that we must address in this emergency communications community. So emergency management, public health, hospitals, and first responders need to be able to talk or share data across agencies, professions, and jurisdictions. I call that across jurisdictions because we know disasters don't stop at the boundary. They don't stop at the city, the county, the state, or the international boundary, even with that boundary being over a wide span of ocean. The Ebola crisis, it didn't stop at the boundaries. And then across professions, we need to share information between our Red Cross and our National Guard and all of those different responders in different disciplines, our healthcare systems, our school systems. So sharing data is a critical, important factor for emergency management. Many systems have their many different jurisdictions and disciplines have their own disparate systems, and they just don't talk across those boundaries. Voice interoperability, maybe that's improving, but data interoperability is a must. So the EDXL family of standards and emergency data exchange language provides a common language or an interface for data exchange across these disparate systems. So interoperability, I'll talk about that just a moment. So no single system can meet all of the needs of emergency management. That would be a perfect world, but it doesn't happen that way, right? So another thing that happens is people build all these one-off interfaces between their different systems. Well, that's just cost prohibitive. Somebody's probably making a lot of money. It's those people that are building those one-off exchanges, right? But that's not what we want. What we want is to be able to have a common interface so that data can be seamlessly exchanged between these different disparate systems without having to change the systems themselves, just at the data interface layer. So what happened when CAP was such a success? EDXL was developed into a process. So in 2003, the Department of Homeland Security in the US Science and Technology Division started a practitioner steering group to form a process to address this need. So we said, okay, CAP is great. We can alert and warn people. We can get those alerts to them in the nick of time. By the way, it's being used, of course, throughout the US and the Midwest right now, with the central US being hit so hard right now by tornadoes. Those tornadoes are being, all of the Weather Service alerts go through CAP and are getting to people's phones and siren systems just in the nick of time, often to save lives. So what did we need next? Well, we needed not only to be able to get the alert to the people in the path of the storm or the threat, we also needed to be able to package that alert and send it to other people. We also needed to reach out to our healthcare providers and see what are the next things that are needed by the emergency response community. So DHS set up this practitioner steering group, reached out to the healthcare and emergency practitioners and said, what do we need next? And they identified the scenarios that would benefit by the use of data exchange standards. So scenario teams were developed and draft requirements were put together. And then after the drafts were put together, we passed that off to a group called the Emergency Interoperability Consortium. Because what's the use in developing a standard if nobody's going to write to it, right? What's the point? So we had to get that input from the product and service providers. So if indeed vendors had a standard, would you write to it? Give us your input. So the vendors reviewed requirements and recommendations were made to the OASIS Emergency Management Technical Committee. Now, all this work was done in the US under DHS, but these are international standards. So we didn't want to stop there. One of the things we did within my committee in OASIS was to reach out to the rest of the world, look at other emergency and disaster response communities around the world, and make sure that we are doing things that would support disasters in any area of the world. So after that process, we would go through the OASIS free and open standard process that's so well defined. And by the way, I really stress free because these standards are free. That's one of the reasons sometimes we don't know who is actually using them, because you can go to the OASIS website that I'll show you in a few moments. You can pull it down and use it. When I say open, it means they're open to comment by people that weren't actually involved in the development. So as most of us know, the public safety enterprise is probably one of the least funded, and people don't really realize public safety is out there until they have a disaster or an issue, and the funding is not always there. So our process is open because we want that input in our process to make our standards better, and of course international for the reasons I mentioned. So we create a standard then, it goes through testing and live exercises and then available for consumer use. So that's the process called the EDXL process. So let's talk about this a minute. So you have an incident. We have a CAP message that's issued. The next thing that we would do perhaps is route that message after it gets to the people on it. Let's send that message to the neighboring jurisdiction. Let's tell others about the hazard and other information. So what the distribution element is, again, an XML data standard that defines an envelope. All right, it's an envelope that can be secure, and it identifies to whom and under what circumstances you want to send or receive data. So basically, it's a routing capability, and it doesn't have to be a CAP message. It can be any structured or non-structured data that you can put in that envelope. It can be secured with the type of encryption that you choose, and you can identify, the sender can, who has the authorization to receive that message. So that's the distribution element. That was the second of our standards. The third and fourth go hand in hand. I'll talk in detail about them later, but the patient tracking and hospital availability. So the whole idea about patient tracking is to be able to capture data on a patient from first encounter, track that data and accumulate that data through triage, through the ambulance service to final care in a hospital. And then the hospital, of course, needs to identify to the dispatch where certain capabilities exist. What hospitals have a burn bed that's operational, that's free and available for use, it's not already full. What trauma centers are available, where's there a respirator? I'll mention too, when HAV first came out, it was used during the response to the Haiti earthquake. This was in 2010. Google, Sahana, and I believe another company out of Virginia all used these two standards to identify, as soon as the internet was up, they could identify the geographic location of where these resources existed. Maybe there was a hospital 2 miles down the road, but maybe it was destroyed. But there are 3 beds they could post. Maybe that respirator has power. Maybe it has a technician. But these are the information that can be supplied in the hospital availability standard, such that for routing patients, the dispatch will know where to go. We'll focus more on those two shortly, but just to round out the other EDXL standards, we have the resource messaging. This is a set of messages to request and respond to a request for resources. Then we have the tracking emergency clients, not necessarily patients, but perhaps shelter refugees and such. This was actually built on the basis of a standard called PFIF, Public Finder Information Format, that Google first developed. After they iterated on that, realizing, of course, they're not a standards body, they are members of our technical committee, they handed that over to OASIS, and we have continued to take that through. So there is a tracking emergency clients standard for evacuees, shelter victims, and such as well. And the last of the 7 is the situation reporting. So most of you that are aware of Incident Command, there are a number of ICS forms that support the emergency manager in the field and in the agency. And so we structured the situation reporting specification around each of the primary forms to make sure that it would support the population of those forms, aggregating that data together for decision makers. So that's the suite of EDXL standards. In summary, CAP, the distribution element, hospital availability, tracking emergency patients, resource messaging, tracking emergency clients, and SITREP. So now let's think about EDXL for healthcare. So as some of you may be looking at what you're going to do for the call for code and the humanitarian needs for healthcare, let's think about how some of these specifications can be used. So this is the TEP context, the continuum of patient movement. So if you look at the bottom left, you have your emergency response functions, your ESFs. That is all in the data communication work that is done in OASIS. On the top right there, you see the HL7 communication. That's the hospital messaging that goes on within. Well, as I mentioned before, where emergency response meets there is in the emergency room. So that is where we have to coordinate this data exchange. So the hospital with HAV can provide for the emergency services, the dispatch, the availability of hospital resources. Then you see a two-way error to and from OASIS and HL7 with the tracking emergency patients. So I mentioned the one scenario with a triage situation with a patient moving into the hospital. And then when they are received in the hospital, they can automatically populate their electronic health record. But what about the case where a hospital has to be evacuated? We had Hurricane Sandy in the northeast of the US. That was a real dilemma because we didn't have a standard data format to take patient data with them to their next care facility and for routine transport. So that's what we're going to talk about on the next couple of slides. So have bed, as you see there where number 1 is hospitals have the capability to provide information about their bed capacity and availability to a local or regional coordination center. In the US, HAVBED was a grant program. Unfortunately, it was defunded a couple of years ago, but we did use HAVBED as the base for our HAV standard. Remember, we're developing an international standard that has to be used across jurisdictions and country boundaries. So we did use HAVBED where that was useful. So in whatever format that bed availability is, it can be provided to a local or regional coordination center. So the kind of information that you have there is bed capacity, status of the hospital and its services and resources. Again, our XML multi-use format is flexible. It can be used during disasters or everyday emergencies or just general reporting. Jointly with OASIS and HL7, we were able to really bring light to the value of this. Now, the hospitals already have this data, and within the HL7 world, they have working groups, and they have a patient administration work group. So that data is provided to the HAV format, and we have a specification that was jointly released by the two international standards bodies that was released just recently. It's a pretty major effort getting two international standards bodies to work together. So that takes a lot of coordination and effort. It actually took us 5 years to get these two through. So there we go. We've got our bed availability information, and we have an incident. We have patient being transported. So as the patient moves through, they're routed based on the kind of injury they have to make sure that the hospital indeed can support them. Now, the TEP, tracking emergency patients, often here in the US and other parts of the world too, you see on the one side there just a flat card. That's called a triage card, and some responders call it a toe tag. Believe it or not, that's what we use. And sometimes mass casualty events, we have nothing but a single plastic card where we check off dead, alive, vitals, and very little information. And then how can that data be interoperable? And in very large situations, even in LA County, for example, that is what has to be used in a large incident. Now, there are several systems out there that are in portable mobile devices, and that's great, but they don't do it in the same format. They don't share information the same way. So TEP allows that information to be shared in a consistent format. Day-to-day use, mass casualty, facilities, and across jurisdictions. So that is one of the core reasons for the tracking emergency patient standard. So that in the middle where the gray area is and the hands shaking, that's that transform. So we can take that patient information and we can send the patients to the unit that has a burn bed available, the unit that has a trauma available. And the emergency room doctor can actually see the incoming patient, what data has been taken. They can see the vitals, not just when they arrive at the hospital, but the vitals that have been taken throughout their journey, any medications administered. So this is key information that the doctor can have to be able to provide very quick response to that patient when they arrive. Now, also in the reverse, step 5 there, we have the patient information being sent back to dispatch so that we don't lose track of patients. That often happens, you would be surprised, and certainly in large-scale instances where patients go to various hospitals and their loved ones don't know where they've been taken. So that closed loop is very important. Now, as the incident scales, and perhaps JPATS in the US, which is a state level system, or the national level system, National Disaster Medical System, that can also be used, and in fact was used. So in 2009 and 2010, when DHS was working on the specifications, the FEMA, Federal Emergency Management Agency, had a live exercise going on in the US. We actually used these standards in their draft form, TEP and HAV, to be able to track patients from Maryland in the civilian area, moved to NDMS, and the patients were moved using aerial transport and placed in hospitals in Missouri, Tennessee, and Louisiana, given their particular patient needs. So these standards were tested with live exercises and found to be tremendously helpful. And we didn't lose anybody, and I learned a lot of valuable lessons. So the TEPT ADT, and ADT is the HL7 term for admit, discharge, transfer. That is the message within the HL7 realm that we mapped to. So where I mentioned have was actually a joint release. HL7 didn't have a standard like that. So they provided the data format out of the patient administration records, and we jointly released have. With regard to TEP, they did have the same data in a message called the ADT. So what we did was an actual transform line by line. So my next slide shows you, and it's a bidirectional exchange, like I mentioned, the need to evacuate hospitals, so it goes both ways and facilitates the ER preparation. So to give you an idea of how the transform looks, this is some of the data on the TEP side and how it transfers to the ADT. So that's the way that works. RAS down at the bottom is actually the pharmacy. That's not part of the ADT record. So that's how that transform works, and it is bidirectional, as I mentioned. So the idea there is to be able to bridge hospital systems and emergency services, cross-domain, automated, real-time data exchange. How many of you have been to the hospital and you wind up, even after going through an ambulance, you have to fill out all that paperwork again? You know, we really don't need to have to do that. We have data exchange capabilities. And I'll mention now too that not only do we do that data exchange, but you say, wait a minute, I've got to have my data kept private. And there's a lot of privacy issues and HIPAA issues with regard to patient data. I mentioned the distribution element, and I want to focus on that just for a few sentences, because the distribution element gives you that tracking ability. Now, it's not in the standard, right? Because these are standards that can be used in systems, but it gives you the data such that you can build systems allowing for that privacy to be protected and monitored, and every step of the way, who has access to that envelope. But you don't have to open the envelope to route the data. And that's a key important factor. You can use AES, DES encryption, or other encryption methods that we don't talk about here, that others choose to use, other countries choose to use as well. So routing that data is key and important, but we can do that real-time data exchange. And remember that envelope can be structured or non-structured data. So you may have a structured TEP data about an electronic health record on a person, but you may also have a picture. You may also have other information about the incident or about the transport. All that can be in that envelope. And that's what the distribution element is all about. So with this, we can advance hospital preparedness. We can eliminate that manual emergency room data entry, which is so prone to errors because you have lives at risk. So during not just daily operations, but EMS hospital evacuation and mass casualty. So effective family and notification and reunification is so much what can be enjoyed by the use of these standards. Seamless patient-specific care on the transition of care. People like to use the term force multiplier and resource optimizer, and certainly it fits that need as well. We can leverage existing systems. Now, nowhere did I say you have to change out all of your hospital systems. Not at all. All those systems, the systems where the emergency room doctor is having a look at incoming patients, they don't have to change that. The difference is on the data incoming, and it's transformed to the proper format for that doctor to be able to use. So we'll leverage existing systems, minimize training, and minimize that duplication of data entry in all of these different areas. So my last slide is a set of resources. The top one is the emergency tracking patient standard itself as released by OASIS. Then the bidirectional transform is there on the HL7 site, hospital availability, and then the cross-paradigm implementation guide in HL7 for transforming from the patient administration message to the have message. So that concludes my remarks, and I'm glad to have the opportunity to share that with you.
Elysa, thank you very much. This was a very, very interesting presentation and everything. Sounds like this would be some pretty good things that could be implemented into people's call for code solutions. It seems like there's a good need for unification of these types of messages, and this protocol seems like it'd be something really useful for that. So thank you for the overview on it, and it was a great in-depth tour of this stuff. So I really appreciate it. Thank you for that.
Thank you.
Great.
No, actually, we have our reference implementation subcommittee, and they are working on that, but they do not have reference implementations or APIs for these different ones. We would be delighted to have folks join us and help us in developing that. We're a small group of volunteers. We've been pushing this rock up a hill for a long time. There are products I know in the field that have developed around these. Global Emergency Response, for example, is one that does have a triage app and also uses the Tracking Emergency Patient Standard. So there are others, but there are none that we have available to you. But we would like to have that as a part of our exchange in the open space to help developers. We will be having an EDXL workshop at the International Association of Emergency Managers Conference, which is in Savannah in November, the IAEM, and we'll have a full day of EDXL workshop there that we hope to be able to share our what we call the EDXL toolkit that we're developing now. And so we're on that path, but we're not there yet.
If you had people that wanted to get involved with this, how would they go about getting involved with helping an API? Do they have a contact point? Should they message you? How should they get involved?
Absolutely. The best way would be on the OASIS site. We have a method to get comments in. If you go to oasis-open.org and you go to committees, you can pull down the Emergency Management Technical Committee. At the very bottom there of this site, you will have how to send comments. So there's your mailing list and comments. Since our work is free and open, as I mentioned, anyone submitting a comment has to agree to the IPR policy. That's how we can make sure these stay free and open. And once you've done that, you can certainly write to the list, and we can communicate with you that way. And of course, you can join the committee. And I dare say many of you have companies like IBM and others that are OASIS members that may just not be aware of this particular technical committee. So we would invite you to join us and help us with this and enjoy promoting and adopting this work more globally.
Great. Thank you again, Elysa. We really appreciate your time, and I look forward to speaking with you again. Thank you again.
All right. Thank you.
See ya. Bye.
Bye.